up here next to you. My directional mic is in there, but the audio will be fine here as long as we speak up. Yep, either way, it's pretty casual.
Okay.
And CTO, right?
Yeah.
Okay. This is Kelly Hill, technology reporter with RCO Wireless News. I'm here today at the 5G Innovation Summit with Jeff Shamblin, CTO of Ethertronics. And Jeff, you just gave us a rundown on some of the 5G challenges and interesting quirks of antennas. So can you give us some key takeaways from your talk?
Well, yeah, it was encouraging to see that in terms of really chipset development and also standards, there's been more movement than I thought, and really the industry is really definitely taking the next step needed to really engage on some initial applications for 5G. So it looks like all the different players in the industry seem to be moving, as I said, a bit more rapidly than I thought.
Okay, great. And as far as antennas, you hit on, I think, there were at least 3 different things that, in terms of design, that are going to be different in 5G than they were in previous generations.
Yeah, I mean, for us, it's very interesting. We're quite excited because if you think about all the 3G, 4G, and Wi-Fi antenna work we've done to date, as we now step into millimeter wave, a lot of things will be changing. Really, number one is going to be that interface between the antenna system and the front end. Cables and connectors go away. Number 2 is it's going to be typically an array in millimeter waves. That's going to be a much more complex feed network or a way of feeding that array. Number 3 is really probably the most important is now that we have got an array and a narrow beam, to optimize the link, we'll have to do beam steering. So we definitely need on the antenna system a link all the way back to baseband to allow us to get that accurate beam point. Beam pointing. So really, probably for the first time, looking at the 3G, 4G world, we'll have to have a direct link from the antenna system all the way back to that digital baseband.
Okay. And I thought another interesting point that you brought up was that because of the narrow beam widths that we're likely to be working with off of those arrays, we might start to see sectorization of antennas in order to get sort of a 360 coverage.
That is correct, and actually even it will definitely be needed on the mobile side. So something like a 5G-enabled smartphone or other handheld device in the future, we'll have to take a sectorized approach if you want very good, robust, full 360-degree coverage. Typically 2, but it's probably going to be 3 or 4 millimeter wave arrays that are displayed around a device to make sure you get that continuous coverage.
And luckily they can be pretty small, it sounds like.
Yep. Yeah, I gave a presentation today, and we've been doing calculations and simulations. Yeah, for a millimeter wave array, 28 gigahertz or higher, it's going to be a quite small structure that's going to support a narrow, high gain beam width. That being said, we do want to stress that now that you've generated that higher gain and narrow beam width, you have that pointing requirement that will have to be dealt with in terms of beam steering.
Okay. All right. Well, Jeff, thanks so much.
Yep. Thank you.
All right.